Can all of you see my screen? Okay. I'm starting. Good evening, everybody. Thank you for joining me today to understand what I've used in my previous organizations for documentation defect removal. It is a prototype which I created in a very rudimentary fashion once upon a time, but then I had to automate a few things which I asked the programmers in the company to do. So this is what I'm going to share. Please bear with me today because I'm sorry I'm gasping because I'm coming away. I had to take a class at SSN College, which is around 38 kilometers away from home. So I got stuck in traffic somehow. I'm so sorry, extremely sorry. Usually I start on time. Okay. So how we'll go about doing this is I will give you a definition of a few, a few terms, and then we'll go about doing the actual other aspects of what is a defect in documentation, how we can calculate a few formulae, and then I'll give you an the algorithm for creating a prototype in your organization, which you can automate it even if you're going to have it in a content management system or a configuration management system. So any other system which can actually automate this process of collecting it and then giving you the details is what we are looking at. Okay. Right now, what I'm going to do is I'm going to show you a page down. Okay. So this is how we'll be doing. And we'll also look at a little bit of root cause analysis. Reason why root cause analysis and the tools and parameters which you should know is because there might be errors which are coming from different people. And these can be customer centric error messages, error requests, or it could be internal customers who are also coming in, or it could be external customers. And we also will see how we have a theory called the zero defect effect, and a little bit of quality metrics, and then the algo. So this is the abstract which actually I sent to and I usually share it always in my slide deck. This is my habit. So what we are doing is we're going to do a percentage also, which is called as a defect removal efficiency percentage, and a defect density. So the defect density I'll address it as we come to that particular slide, because there are two types of defects in any documentation. One is author-induced and other is technical-induced. And we also might look at a few formulae for productivity percentage to calculate productivity. Today, productivity has become the buzzword in the industry because they want to look at it in a very big way. Many of the organizations are going the productivity way, and there is a particular tool also to calculate your productivity in terms of how many hours you're sitting on your computer. So this is something which we need to see. So a few definitions of defects is we have a few things which I'm not going to read through it, but there's always a defect analysis where you have to find out the root cause of that particular defect. That is how the defect analysis is done. And one minute. And then there's a defect prevention also. One thing is being proactive in prevention and being reactive. So when talk about proactiveness, it means that I should anticipate what type of defects the customer will raise. And there is a reactive which is based, which we are always going to do. So that is defect prevention can be addressed if you know the root cause. That is what is the meaning of this defect prevention here. And the defect source can be at any stage in the software development life cycle, or it can also be anywhere in the documentation development life cycle also. It can also be, it is also in the design phase, it can also be in the marketing phase. We don't know when the defects have crept into the software. It can also be because the customer has not given us the requirements properly. So that when we look at all these root causes, these are what we have to analyze. That is why the defect analysis becomes very important. The defect prevention also will can when once you know the root cause, then you can draw a matrix, and the matrix is very easy to define what it is. Okay, so what we call the escaping defects, some of the defects will escape when it creeps into it, it'll come till the coding stage, and that's when they'll find out that there's a defect. So these are called as escaping defects, and these escaping defects will be carried forward from one phase to the other next phase. I'm not just talking only about the sequential or the waterfall method or the spiral method. The defect source can also be found out from the agile in the agile environment also. Okay, how you do it is about how we look at it. So the triangle of constraints, I'm just going to explain why we need this. The reason the reason we are looking at the triangle of constraints is, one minute. So the you all of us know that scope, cost, and schedule is the basic corners of the triangle, and quality is the center. That is how it was done. The scope could be features, the functionality of the product. The resource could be the cost and budget for the entire thing. It could be from the start point A to point B. The cost and budget could also be, if you're looking at also something which are increasing or decreasing. The scope increases, the cost also increases. So that the proportional, the direct proportional it is there when you look at scope, resource, and time. So scope changes, the time also gets affected. When all the three are interrelated and they get affected, then your quality will be affected definitely. So that is how we are looking at triangle of constraints or the iron triangle of project management. Okay. This further became the project diamond, or what we call the iron triangle, also made quality as an important aspect and gave it this sort of a project priorities. Okay, so this is how the triangle constraint changed over a period of time. Finally, if you look at this, this is how the triple constraint in project management came about, where you have the schedule, scope, and budget, which is the red triangle, which was the base once upon a time, and then became risk, resources, and quality. Risk is something, risk management is very important in the project management life cycle. Okay, if you have any doubts, please send it through the chat window. I will still answer that. Okay, am I going too fast, or is it okay? All right, I'm assuming that it's all right. So finally, if you look at the waterfall method, okay, the waterfall approach and agile approach, you notice that there's a thin dotted line. Okay, and we are looking at variable and fixed in the triangle of constraint itself, and there's a regulatory approach. You will notice that in the waterfall, the scope is always fixed and the rest of it will be changed. In the agile approach, the scope is variable, but the quality, cost, and time are fixed. Okay, that is why this inverted triangle, and you'll notice that there are advantages and disadvantages in both approaches, but we are trying to adopt and adapt to new approaches because it's easier for us to give it in chunks. Okay, and the regulatory approach has the quality again, it's an inverted, still it's an inverted, but the cost becomes a variable, the rest of them are sort of fixed. Okay, this is how we should understand the. Okay, now if you look at the root cause analysis, the symptom or the problem, I call it the weed, is above the surface, and it's just very obvious for us because we know what it is. But the underlying causes or the root is below the surface and it is not obvious, and that is where we need to do the analysis. Okay, so we are looking only at the underlying causes, not the one cause. It could be many, it could be from any other quarter also. Okay, the root cause analysis is the key is to be identifying the root, and it can, as I said, it can occur in anywhere in the project life cycle. It can have a major or minor impact on the customer, but how do I analyze? So if you look at some of the features and you feel that the impact for the customer is going to be very high, then you put it under a major. This could, I'm talking only about documentation in this case. When I'm looking at the root cause analysis, I'm not looking at the design aspects of the software. Okay, so what do? I identify, I contain it, correct it, and prevent it for the next time. It should not happen again. Okay, So the more you do, the more mistakes you will make. So problem solved. So he's sleeping. He's not actually doing anything else. Okay. So please remember, we'll look at ICCP, which is identify, contain, correct, and prevent. Okay. So there are different types of tools. I'm not going to go through all these tools. I'm just giving this slide deck. I've already shared it. So you people can probably understand these models, and whichever is it is conducive for your atmosphere. It could be a combination. That is the way you have to use this root cause analysis. Okay. All of us know the Ishikawa or the fishbone diagram. And there's a Kepner-Fourie model, which is very beautiful, divergent and convergent thinking, and 5 whys. You have to ask, this 5 ways is an interesting theory. You have to ask why does this happen, why does this happen, again 5 times. So when you come to the 5th time, when you ask the 5th why, your problem is solved, or you have found the root cause. That is why it's called the 5 whys. Okay. I'm not talking about FMEAA because that's a big huge model, and also the affinity KJ affinity diagram. This we all know. Plan, do, check, act, which is what which we do usually. It's a combination. But please go through some of these tools, because this is the scope of this particular presentation is not the root cause analysis. We are only looking at it from the just the theories. Okay. So I'm not going to go into it in depth. Okay. So usually the parameters for root cause analysis is conflicting or vague requirements, and it is undetermined causes. Okay. Vague requirements, all of us know. When you look at a particular design document, or even a functional specification document, what basically happens is they actually give, if they don't know the design element, or the marketing team has not percolated the information down in the right way from the customer or the client, then you get a conflicting requirement or a vague requirement, which will not be actually correct, but it will still carry forward because they just want to satisfy the customer. And sometimes what happens is they will drop this particular requirement in the release, software release, but they'll promise that it will be done as a patch release within a month or 2. Okay. So usually it is within a month if it's a patch release. So the patch release will have all the requirements which they probably felt it was vague, and they still take it up. So the parameters is the root cause will happen because the conflicting vague requirements, and because of this, what we would have done is we would have already documented something there. So some of them are undetermined, we don't know the cause. You just can put them in a separate bucket. And if there's a coordination failure in your project management meetings, then what happens is you'll again have some problems. So the parameters are different, and conflicting vague requirements and flawed design go hand in hand, even though I've written it as a separate point, because this can be also separate. It can also go hand in hand with conflict vague requirements. Sometimes the out of scope. All of us know that in a software, if it's a product even in a service company, usually what happens is we have a critical mass line. The critical mass line, above the critical mass line is what features will be going for that particular release. Below the critical mass line is what goes into the next release. That is the standard rule of software project management life cycle for scope. So out of scope is like this. So if supposing above the critical mass line, if some of them are going to creep in, and we don't do it because we still feel that is very difficult and vague requirements, what happens is we put them in the out of scope bucket, one way. The second is, if it is below the critical mass and you try to bring that feature into this, then your design elements are not ready, or your descriptions are not ready, then it becomes again an out of scope. Okay, excuse me. The third party errors are more of errors which, suppose you have given a particular piece of code to somebody else to do it, a vendor, and what happens is this vendor is not going to give it to you on time. Sometimes it happens like that in some organizations. A little bit of a chunk will be given to somebody else. So when the third party errors can also be root cause parameters. Okay, and naturally business knowledge, lack of technical knowledge or the domain knowledge can also affect your way of documenting things. Please note those apples, all of them are round, but you have a square. I purposely put that diagram there because we will not be able to see it unless this is in the center, so you are able to find it out. Supposing it is with the bunch of apples, then what happens there is you will not be able to find that unless you go through very minute way of looking at the parameters and then eliminating that particular apple which is in the square shape. Okay, we cannot solve problems with the same thinking we used when we created them. So that's very true, because some of the problems have to be taken out in a different manner and analyzed and broken down into chunks to analyze it if it's going to be a very huge document. I remember doing it in the BFSI domain, which is the banking, financial, security and storage, and insurance. Sorry, storage and insurance. The BFSI domain is very, very critical because it's dealing with money and banks. So we cannot use the same way to solve problems if the way we created them. And the documents were very huge, 1,200 pages running user manuals, but all of them were required by as a compliance issue. So we used to find it very difficult when the customer defects used to come in. So that is one example. I'll explain it maybe later. So there are a few more parameters. Before we go into the parameters, how many of you can interpret the figure which I've given here? What do you see basically? Any answers? Not the RECA cycle. I'm talking about the black color thing which is on the left side. RECA cycle is a nice one, but what do you see in that figure if you look at it immediately? Yeah, a duck, definitely. Yes. Duck. Yeah, okay. That's right. A duck and a rabbit. Because turn this to, anti-clockwise, one cycle, you will notice that it's a rabbit. So your requirements will always come like this. They will either be a duck or a rabbit, and you will have to find out what they are if it's going to come as a combination. Please remember that it is all the way we do the requirements analysis. Okay, so it means that we can put them under inadequate specification, inadequate processes, and so on, and the list can go on, the parameters can increase as you think about it. So always remember that you should be able to also catch the rabbit, just not the duck. Okay, that is what was the diagram I placed it here. The root cause analysis is break down multiple problems into components. You identify and specify the problem correctly, because these are all phases of the root cause cycle. Okay, analyze the root causing using a systematic approach, and then verify the causes and take corrective action. How you do it depends upon your organization, but please remember these are the phases which go for a root cause. Okay. So there's a person called Philip B. Cosby. He first formulated this approach called the zero defects effect. His book, Quality is Free. Please go through this book. It's a fantastic book. I've read it and I liked it very much, especially when I was doing some auditing of some documentation projects for a CMMI in a company which they were going in for documentation. I was an auditor, both internal and external auditor. And this book I read at that point of time, and it was a fantastic book. Please go through it whenever you find time, if it's available, and you need to know this. So what is the zero defects approach? It is basically the goal is to have 0% defects in your documentation. That is the goal. And how do we do it? Okay. So that's what we need to look at now. So Philip B. Cosby is the person. So these are some of things. I'm not going to read this. Please remember that this is a big, I just put it as for your information slide, because this was a synopsis which was taken from his book. Okay. So we have a few things which you need to do. And this is, if you follow these things, he says you can come to the zero defects effect. Okay. So you please go through this. I don't want to read this because this is not the scope. Okay. we all know that Tom DeMarco explains in controlling software projects, you cannot control but what you cannot measure. That is the reason why we should measure the projects or measure the quality of the projects. So if you define something, you'll have to be able to measure it. If you measure it, you should be able to analyze it. And if you can analyze it and find some defects, you should be able to improve it in the system and then finally control it. So once you control, the defining aspects will reduce. That is why we call the DMAC cycle as a very interesting cycle in terms of controlling software projects, in terms of measuring. So define, measure, analyze, improve, and control. So setting the standards is important, which all of us do. Like you have your style guides. You might also have a few other things which might be standards, which will be industry standards. For example, if you're in the healthcare, you'll have to set HIPAA standards. If you're in the aerospace engineering domain, you'll have to set the S1000D standards. If you're in the banking and brokerage and security things, you'll have certain standards set for in the different banks across the world. So each standard also should be known. So you should know the setting the standards part of it. That is done. Then you'll have to manage your projects and capture the metrics. So, but for doing capturing metrics, this cycle can be used. But please remember, you cannot control what you cannot measure. So measuring is important. Okay. So these are some of the quality metrics, which if you people have not tried it out, please do try in your documentation. So the defect density is the number of defects, whether it is going to be, that's what I've talked about in the initial thing, author-induced defects and technical defects. I'll explain a little bit of author-induced defects, why I classified them that way, and why I classified them as technical defects. Technical defects are those defects which will come in two categories. One category is when people cannot understand what the technical guy is telling. So I have interpreted it in a different way. Then that could be because lack of business knowledge or technical knowledge. So that falls under the technical defect. It is not an author-induced defect because I didn't understand. One more is, if the requirements are so vague and the technical guy or the SME is not able to explain it to us properly, then they again become technically induced defects. Author-induced defects will come under various categories, and I have categorized them as around 5 or so. One is the English mechanics, where you're talking about your building blocks of the language. The second is your formatting. That again is something. Why formatting? I'm including header, footers, cross references, hyperlinks. Okay, it could also be if you're going to do data XML, you also have to look at all the cross references, whether it is there, warnings, notes, caveats, or even any other important notifications. All that will come under formatting and author-induced defects. The other is your basically your table of content, table of all the hyperlinks, which is generated by the system, but which we have not, probably will not update. See, the automation is happening within Word or FrameMaker or any other system. Automatic TOC is created, automatic everything is created. If you don't have a checklist which is checking whether you've done all this before you compile that entire book, then what happens is we'll have a defect. So if your author-induced defect could be, I wouldn't have updated the TOC, or I wouldn't have updated the list of figures or tables or whatever you call them there in your organization. So all this will become your other type of defects, which can be also given under a heading. Okay. Then the other author-induced defects could be typical quality defects, which are affecting, because it could also be because the scope has changed and you have not, it has also become obsolete. The feature has become obsolete. It is not there in in that particular software anymore. Whether it is a UI change or if it's going to be something else, if you have not included and a customer raises a defect request, then what happens is that also becomes an author-induced. Even though you can argue that some other author has done it previously, it is not my responsibility. If they raise the defect request, then it becomes an author-induced. And who's author right now? You. So it will only fall on your head. That is basically, that's how they're looking at defect density calculation. Okay. So if I'm going to look at the total number of defects, there are two ways of looking at defect density. number of documentation defects divided by the total number of defects for that entire project. That is one defect density. The further down, we are trying to bring it to the granular level for the documentation is author-induced defects divided by the total number of documentation defects. One. Total number of defects in the technically induced defects divided by the total number of defects in the documentation. So this defect density can be calculated in a different way. So if I'm looking at the first one, it is for the entire project. So you will know whether what percentage of the defects is yours and what percentage is coming from the technical side. So it will be easy for you to analyze. This is the type of big, the data analysis we are doing now for documentation defects in many organizations. At least I've done. I didn't know that it's now today called very fancy names like big data analytics back in one organization, and continue to do it wherever I go. So, and I find that the defects density comes down at least drastically in terms of percentages. Okay. So the defect removal efficiency is calculated as number of defects before release and defects found by the end user is D. Okay. So this is the type of defects before release. The number of defects before release is captured where? Internally. Usually it is whether in your peer review, your SME review, your technical review. When you calculate the number of defects, you have to document them before releasing the software to the customer or the client or to the market. Okay. So if your defects is very high, whether it is in a software or not, or even in documentation, your market share in the business environment will definitely fall. Okay. So that's the reason why people are very keen on calculating defects nowadays. So number of defects before release divided by E plus D. And the end user will also raise defects. So you'll have to take into that consideration of all of them together. Will give you the total size. All right. So we have to remove this. Any doubts so far? Can I proceed? Okay. Okay. So they've written as when does a defect become a defect? So for example, when you say defects found by the end user, there could be errors not found by the end user, found and not reported. Similarly, the defects before release, doesn't it depend on the volume of documentation, also on the effort spent in catching these errors? Okay. Can you please give an example for defect calculation? And that I will be doing in the next few slides. So to answer this question, when does a defect become a defect? So when you go through a life, to the cycles of reviews, whether it is a technical review or whether it is going to be a review done by the peer reviewers, and you have a checklist where you're looking at all these defects, you have to define what is a defect. Okay. So for example, if I've said that TOC in your checklist, you have all these TOC and so on. I'll show you an Excel sheet that also will give you an idea. Okay. So this is how we should look at entire defects. So if I show you a checklist, probably you will be able to understand that better, Nibu. So that was asked by question was asked by Nibu. So I'll answer that. Once if I still don't answer that question, then you can again ask me that. So let me show you the Excel sheet also. Okay. So this is how we do it. And yes, yes, definitely defect depends upon the complexity, because we have the complexity in the terms of if you're looking at the feature complexity and also priority. So in a documentation, you can do all the features at one go, but the critical mass line, above critical mass line, there will also be a priority list given by the people or by the programming development team. So it depends both on complexity as well as priority. Okay. So if you can look at complexity, it means that you can classify all your features as high, medium and low. And it depends also on high will be where it will be a new feature or something which is the new scope, or you're looking at something which is going to be only released with this particular sprint or in that particular software release which is going 6 months down the line. Then what happens is, if the complexity, if you don't understand it and then write, definitely defects will creep in. So defects, they'll depend on complexity, on the priority of the software features. Okay, does that answer your question? Okay, right. So let me go here to this. These are some metrics which I've written down. I don't know how many of you use it, but I use all of them in my in my management. When I wanted to do an effort variance of my effort, because effort estimate for a particular project would come new for me, I would like to know how much of variance I had because of all this learning curve and every other parameters I looked at. So quality metrics I used to capture in a very different way. uh, I will share this with you people. If you need to me to answer any of them, I will take it offline, and I will definitely also answer each of them because I've worked on them extensively. Okay. The one thing which I really love to give you, because we are talking about a defect calculator, is the review efficiency. The number of review defects divided by number of total defects review plus post shift minus defects could be authored, induced, or lack of technical inputs. This is a formula which I've used, and it has been very effective for finding out the review efficiency, because I want to know how many of us have reviewed in our way of reviewing. Also, have we captured it internally instead of coming as post ship? I don't want it to be captured from the end user. I don't want it to be shipped and then the released and then I find some defects from the user. That is not what I want. So how is my review efficiency internally? That is what I wanted to look at. Okay. So I can take this particular slide 15 offline for anybody who's interested. I'll share my mail ID. You can definitely write to me. I will explain. Okay. So as I said, so Kunal, this is the thing which I wanted to show you. So complexity is high, and I've given explanation of what is a complex thing. You can add anything more. This is not restricted to only this explanation. Please note that I've just given it as an example description of a high for one of the projects. It might be vary from company to company and domain to domain. It also might vary for audience also. So it depends on how you want to present this. So the classification should happen. I told you that we have to define in our DMAC, right? Only if we define, we can measure, right? So that is the reason why I said you have to define all this as a document for quality in your documentation. So you have to document it and give it as a particular handbook for all of them, so that it will be easy for them to keep this as a rule in your team. That is the way we have to run the documentation defect calculation. So I've just given you some example of high, medium, and low. Please add whatever you want to in this feature classification. So the timelines are valid. Again here, this is one more. If it is very complex, I'm assuming that I'm just giving you some ballpark figures. Okay, will take 3 months to complete for one resource or head count. This is also because I told you that resources was there in the constraint of triangles, the black one, when you had a star, right? So the resources I also have to define. So when I define the resources, I'm saying it is very complex. So it will take 3 months for that particular person to complete it. One resource or one head count will take me 3 months. Similarly, this is complex, medium. It will take minimum of 2 months to complete for one resource or head count. So if I have to increase the resources, then I also have to see if my software entire team, my budget is applicable for the documentation team also to accept one more resource, whether it's going to be a full resource head count or a half a head count. That means 50% he'll work or he or she will work on this project, 50% she or he will work on some other project. That is the meaning of half a head count. So it can be low or moderate, which will take 2 weeks to 1 month to complete for half a head count. Okay. The disclaimer is you have to write this also in your when you're doing the description. These timelines are valid provided no further GUI changes or GUI changes or functionality changes happen. Please remember, if you provide only these, then only these will work, is what you have to tell in your project management meeting. All right. Okay. This again, I've given it as for your information. All these are quality metrics. There's a team stability index, which we usually use for peak plant staff for that particular project and so on. When you look at your Microsoft project, these can all be put in there. And you also have to look at the resource utilization and requirement stability. what is interesting in this particular 18th slide is requirement stability. Number of requirements identified, that is a critical mass line, and number of divided by number of requirements plus changes to requirements, the scope change into 100%. 100, sorry, will give you the requirement stability of that particular project or your documentation project. So that time you can argue that this came in at this point of time, so my writers cannot do it. That is how I've argued and won some time for my writers. So you know that the number of requirements has been already identified, because you know that the critical mass line is there. Above those only we have taken the features. The number of requirements plus changes to the requirements, the total number of requirements which was there plus changes, the scope has changed. So the changes to requirements will give you the total number. Okay. So requirement stability is again a very important thing. So when you have requirement stability also addressed in the project, then you can argue that you cannot expect. So why will defects creep in? You may ask. This is one of the parameters. If you have, as I said, requirements, change in requirements. I remember the parameter list. The change in requirements will give you this. That is why I wrote this as the 18th slide. The last one is very important. Okay. Okay. Now this is the algo. For the before I go into the algo, please, if there is any questions, I'll take it now. Otherwise, I'll continue. Any questions? No? Can I continue? Okay, I'm continuing. Okay. So I'm giving you a simple algorithm for creating your own defect. Okay, some question is coming. Just let me see what this question is. Okay. Yeah. What is requirement stability? Any practical example? Okay. Let us say you have the number of requirements is features in this case. Okay. Yes, I will show you the. A simple one. I'll show you the Excel sheet, definitely. See, so requirement stability in this case is the number of requirements I'm talking about is number of features which you need to document. Okay. So this will be dependent on the number of requirements which has come to the marketing team from the client, which has percolated down to the development team. Okay. That's why I wrote it as number of requirements identified. All right. So far, so good. Okay. So I might again have that tabulated as on basis on complexity and also on priority. So that is the number of requirements identified. All right. So we have completed, say, maybe a 3-month on that particular documentation, and then I'm maybe already on the 5th or 6th sprint, or even I'm going to, if I'm looking at the spiral methodology or the sequential methodology, maybe I'm finished 3 months of it. Then I noticed that a new set of requirements has got into the above critical mass line. At that point of time, it has to be, you have to find out the stability of that particular for us in terms of how much more documentation I need to do, because scope has changed. That is what I mean by requirement stability. That means how stable is the way we have looked at it can I'll explain. I'll answer that question. So the requirement stability is basically the requirements which have initially come into for the documentation, and then how it changed because the scope has changed. So Kunal, does that answer your question? So I have added number of requirements plus changes to requirements as a total number, and number of requirements identified initially as the one which was identified as above the critical mass line. Clear? All right. So this applicable for feature description guide, not necessarily so. You can have different types of getting started and installation. Installation it will be the number of steps which you need for installing. So you can take it as that as a functional point. Please remember documentation, like how coding is number of lines is a functional point. For documentation, you can have it as features, you can have it as steps, you can also have it as number of clicks and so on. So functional point will differ from documentation to documentation. So, and also the type of documentation I meant, not the entire set. So getting started installation also can have the requirement stability. It will also change, right? So installation, why will it change? Because if it has added a new feature, then I have to look at it. So installation is two ways. Installation guides can be written for only a single product, or it can be written for a cluster. What is a cluster? Cluster is something where I'll have many permutation combinations of a particular product. So a client will have product A plus product B plus product C installation. One more client will have product A, B, and D. So the cluster will change each time a client its installation happens. So the client installation might be very different for different people when it comes to a product company. So that's why I said requirement stability will change if the installation itself will change. The product, the procedures or the steps in change. Yeah, thank you. I can understand. So 10 minutes I have. Okay, all right. So, so is there any limit or range good requirement stability? Right now, they don't have anything like that. No number, no magic number. So Satish, does that answer your question on requirement stability applicability? Okay. So there is no limit or range right now, because it depends. It depends upon the software. It also depends on the number of features. So you can create your own stability for each product documentation or any of the documentation which you create, because each will be different. I don't have, for example, I might write 100 features, but in that 100 features we don't know the complexity of all the 100. They might be very simple. 75 might be very simple, low. I might have only one high and the rest medium. So my requirement stability is different for different organizations. You should calculate it. Okay, all right. Okay, I'm going for the algo now. A very simple algo. So what happens is, usually none of you, maybe if you're not in the management, and I try to make it very transparent for my writers, because they should immediately get it. And I made it a point in all the organizations I go that the development team should give me the customer change request database, should be accessible to all the writers. They should be able to go and identify what documentation change requests have come. I don't want it from the development team or the testing team coming and telling me that this has to be changed at the nth hour. No, I want to be proactive. If it has come, it has come. So I want access to the database. So the main database, usually they will have a change request from the customer. Okay, it's usually called as customer change request. Different organizations might have different things. Some of you might call it as document change request. Some of you might call something else, whatever it is. Okay, in this case, I'm just giving it as an example. So it is a customer change request. It's a database. You have to check for the CCR category or type. So if the CCR category is equal to doc, they'll have all these features. That is, they'll categorize it as this is a coding or testing changes, or it is a design change or anything like that. They'll have different parameters. So you then save it in the doc database. You will have a doc database separately in your content management system. Just push it into that doc database. Okay. So you have to write program for this. And check for database. The subtype could be software documentation, hardware documentation. It could be training manual. It could be technical illustrations. Also, you might have errors. All of them will come under doc subtypes. Then filter for doc subtype as software documentation. If you're going to do only software documentation, filter for product line. Okay. And then check for error type, whether it is author or technical induced. So now how do I check for this error type? Many of you might have that question. So when you look at the change request which has come, that itself you can classify. So that is what I mean by check for error type, and write it as either it is author or technical. So immediately the person who's actually doing that particular documentation will pick it up, and then we'll start working on it. So count the errors in each category. We'll also get the total defects in the document, right? And then calculate the defect density percentage as follows. So author errors plus technical errors divided by the total number of errors in the product, or as I told you, the different formula you can convert it. Remove the technical errors, only author errors divided by the total number of errors. That's why I didn't give you whether it is in the software or it is in the documentation. I just given it as total number of errors. Total number of errors in the documentation into 100 will give you the defect density percentage. All right. So sometimes errors and failures are not relevant. So the Leaning Tower of Pisa is a final beautiful example. This is a beautiful book, Mistakes That Worked. Okay. And at what phase of the product life cycle are the errors and failures not relevant? Usually in the gathering phase, sometimes when before it goes into the design phase, when you're going in through an analysis phase and feasibility study, that time errors and failures are not relevant. Or even if you're creating a prototype, right? So these are some of the product life cycle stages, phases, where you don't mind if errors creep in, because errors will give you the solution also. So this I like. You have to innovate. You can innovate that algo as much as you can. So none can destroy iron, but its own rust can. Likewise, none can destroy a person, but his own mindset can. Is something which I like very much. So I added it. Okay. And this is my mail ID. You can write to me anytime. Do I have time to show the Excel sheet for a minute, Abhilasha? Okay. Let me. I'll stop sharing it for a minute, and I'm going to pull out that document. I mean that Excel sheet. All right. So any questions, please ask me if you want to. So I have used this simple sheet like this. I'm sharing the screen now. Okay. You people can use it however you want. You can increase this, but this is something which is copyrighted. So right now I can't share it, but I can show it to you. Okay. So I've given some instructions. Then there's a quality metric sheet how I capture, and then I'll do an editing analysis. So instructions are like this. Uh, can you see the screen? Okay. Somebody had something. All right. Okay. So English language mechanics, I've added all these. Okay. And then for formatting, I said indents, uniformity, tables formatting, and so on. All right. Image formatting also. And template usage, deviations, exceptions, and all these under formatting and index also. In technical inputs, SME, clarity in concept, technical unclear depiction of concepts, process slippage, timelines, target dates, adherence, because when I do an estimated effort variance, if I've slipped in timelines and non-adherence to process, not raising document change request or not raising something else, and content management issues, in this case I used documentum, so I wrote it down there. All this come under process slippages. And graphics, images, clarity, I put it as under one more category, and the rest of them I put it as others. So when I put the quality metric sheet, I'll capture it like this. So number of defects in each. So for example, if I'm going to say 3 defects, the total defects I will put it as say 16, sorry, not 167, 16, and I'm going to put this as say maybe 5, and I'm going to put this as 3. Not technical inputs, you'll usually get something like that. Process slippage, no, graphic, I'll put it as some say 6, and so on. So this is how you can calculate. This is a simple calculator. This what I did is I asked a programmer to automate it to include my algo. Okay, got it? So this is a simple Excel sheet. So editing analysis can be done by using the severity, impact on the customers. All this I can try. Whatever I want to do, I can add as many as I think want in this documentation and do it. So the quality metric sheet is captured in your review cycles. All right, clear? So that's about it, folks. Any questions? Please go ahead. Yeah, I have already shared it with Abhilasha, the slide deck. So please, I think she'll share it with all of you who has joined. So any questions? Okay. So improvement or change. So what happens is we have done the process. So once you know that these are the defects in these categories, you will know that this is how you should not be doing it. And if you follow the checklist, automatically you will notice that the defect density in your documentation is coming down, because you will not repeat the same mistakes. Thank you, Nibu. So that's the reason why you'll notice that improvement or change will automatically happen for you. It is a practice. It doesn't happen overnight. You'll have to get used to the idea of using something like this in your organization, and it should come under everything else. All right. So process slippages is more to do with if you're not. Thank you. So my pleasure. So it's process slippages is, for example, if you have a process in your team or in your organization where you have to go through a process to start your documentation, and you don't follow that process, so how will you know what you're working on? How will your project manager know what you're working on if you don't tell them that you're working on it, but however your process is? So for example, I used to always raise a document creation request, or whatever we call it, so a DCR. And by not raising a DCR, when I take out a report from documentum, I will not know whether that person has started on it and has given me a priority or a complexity there. So that happens only if that happens, I will know that it is. So if they're not adhered to it, it's a non-compliance for me. It's a process slippage. So I will write it as, if you're without raising a DCR, or without raising that particular thing, he's just going through it. How will I know how many features you worked on? So that is the reason. That is one good example of a process slippage. So your processes can be also brought into this as a defect. If you're going to make that way, then people will adhere to your processes, and it will become automatic. All right. Does that answer your question? Okay. Somebody asked that question, so I'm not sure what the name was. I'm sorry, I didn't get the name. Shushant, is it? Okay. So any other questions, folks? Okay. Okay, no other questions, then that's about it, folks. Anytime you can write to me, speakkiranmayee@yahoo.com. Okay. I stop sharing the screen.
Thanks, Kiran, for introducing us to this prototype. Folks, if you have any more questions, you can directly write to Kiranmayee. Kiran, this was a good refresher for us to assess our documentation with the quality metrics that you explained. Thank you.
Thank you. Thank you all.
Thank you, audience, for being patient with us. We're sorry for that glitch in the beginning. We have the session recorded, and I'll share the recording and the slides in a couple of days. I'd like to thank our webinar platform sponsor, TechnoRights and Makaran. Thank you so much. Thank you, STC India and the Admin Council for supporting us through it. If any of you all have, any of the participants, if you all are interested in conducting a session, so please write to me at webinar.manager@stcindia.org. Or if you have any particular topic that you want to hear about, please let us know. So that was all for today. Thank you and good night.
Yeah, my pleasure. Yeah, my pleasure. Thank you so much for the active questions and participation. Please do write if you have any questions. I will definitely answer. Might be a delay in answering, but definitely will do it. Thank you so much. Good night.